Find the critical numbers of h of x equals x cubed plus x squared minus x plus 1, and then use the second derivative test to determine which give local maximum or minimum values. So to find the critical numbers, we need the first derivative. That is going to be 3x squared plus 2x minus 1. This is never undefined, so the critical numbers will come from when this is equal to 0. And if we want to try and factor this, there are different ways of doing that. I'm going to use the AC method because that's the method that I end up teaching the most often. You can also use other methods as well, but we've got a times c as -3 and b as +2. So we need two numbers that multiply to -3 and add up to 2. It's going to be 3 and -1. So we use those numbers to split the middle term, 3x squared plus 3x minus x minus 1. And then we can use grouping to factor. 3x times x plus 1 minus 1 times x plus 1. And that gives us x plus 1 times 3x minus 1. And this is equal to 0 when the factors equal 0. And those are going to give us our critical numbers, which are going to be -1 and 1/3. I'm setting those equal to 0 and solving in my head. If you can't do that, then you can certainly write them out yourself. But these are our critical numbers. Then to test whether they give local maximum or minimum values, we will need the second derivative. And to get that, we have to differentiate the first derivative, and that's going to give us 6x plus 2. Now, if we evaluate this at -1, 6 times -1 is -6, and -6 plus 2 is -4. So a negative second derivative corresponds to a frown, which is concave down, but that gives us a local maximum. So we have a local maximum, and that comes from x equals -1. And then we need to look at 1/3 for our other critical number. 6 times 1/3 is 2, and 2 plus 2 is +4. That is going to be a smile shape, which is concave up, and that's going to give us a local minimum at x equals 1/3. If we wanted to find the function values so that we could, for example, plot those points on the graph, we would need to plug these critical numbers into the original function and evaluate the function. And that would give us the points that we could plot for our local minimum and local maximum values. And that's something that we're going to be doing very soon in this course. But for right now, I just want us to figure out if we get local maximum or minimum values. We're going to save those extra calculations for when we're going through and doing the graphs.